Why did the programmer cross the road? To look up the meaning of the word dictionary. I'm really sorry. Hello and welcome, everyone. It's nice to see you again. My name is Noah, and this is Arcade Games. We're going to try and break that time record again this week with Dictionaries, the last stop on our collections side quest. With arrays and lists under your belt, Dictionaries should be super easy to understand. And we're going to take a similar approach as we did in the last video, getting to the bottom of what dictionaries are, how to declare them, and how to use them. So, without further ado, dictionary. A set of data in which elements are stored and retrieved via key rather than index. So, with arrays and lists, we've been working with indexes that start at 0 and go up to 1 less than the size of the collection. If you want to retrieve or modify a value in the collection, you need to know the index. Dictionaries can be thought of as lists in which we, as the programmer, get to decide how to retrieve and modify values. Would you like to store values using your own integer IDs that don't match up with the index numbering? You can do that. Would you like to store values using string tags so they can be more meaningful to the functionality of your game? You can do that too. Heck, you can even go super weird and store elements using similarly typed objects if that's your thing. And that's really the only limitation for the data you store or the keys you use to retrieve that data. All keys in a single dictionary must be the same data type as all other keys, and all values in a single dictionary must be the same data type as all other values. Keys and values can have different data types, but keys need to be a thing and values need to be a thing. To declare a dictionary, ensure you are including the system.collections.generic namespace at the top of your file. Just like lists, this is the namespace where the dictionary class is defined. Where you want to declare your dictionary, type the keyword dictionary followed by 2 data types in horizontal chevrons separated by a comma. If you recall, the horizontal chevrons are how we notify a class or method that takes generic types what specific types we want them to handle in any given instance. For dictionaries, the first data type we pass is the data type for the keys we want to use with the dictionary. The second data type we pass is the data type for the elements we want to store in the dictionary. As you can see from this example, those can be different, but they can also be the same. In this case, we are declaring a dictionary that will store float values, and we will retrieve those values using integer keys. Then, like with lists, we can follow our dictionary name with the assignment operator, the new keyword, a pair of parentheses, and a semicolon. If you would like to initialize your dictionary on declaration, you can do so using this pattern. After the new keyword in parentheses, in one pair of curly braces, put more curly braces for each key value pair separated by commas. Don't forget the final semicolon after the outer curly braces. In this example, we are declaring a dictionary called My Dictionary, and we're initializing it with 3 key value pairs. The key 100 will return the value 2.3, the key 150 will return the value 4.6, and the key 175 will return the value 3.9. Interacting with dictionaries is done the same way you'd interact with an array or list. You'll just use a key instead of an index. In this example, ours dictionary is a dictionary of float variables stored via string key. The value of the float stored under the Tuesday string key is being assigned to the new float variable, hours. Here, points earned per level is a dictionary that stores integer variables using keys of the float data type. The element stored under the 1.5 key is being assigned the value 3268. Then we've got this one. Here, options is a dictionary of strings stored via integer key. We are assigning the string value stored under the key -10 to the response variable. And last but not least, we have this line. I'm gonna give you a second to step through this one. It may be a little cheeky and does require you to make an assumption. Okay, so this line assumes we have a dictionary of character objects called characters. We can refer to each character in the dictionary by their name, in this case, Bob. The entirety of the line is printing the likely Boolean value of can equip wand from the character Bob. Now, if you try to interact with a dictionary using a key that does not exist within the dictionary, you'll get a key not found exception error. Just like with lists, there are a whole host of methods that can be used with dictionaries. And just like with lists, I'll link the MSDN documentation below so you can browse those methods in their entirety at your leisure. But I'd like to share some of the more useful methods now. You can add an element to a dictionary using the add method. The add method takes two parameters. The first is the key you want to reference the element, and the second is the value of the element itself. If you attempt to add an element using a key that already exists in the dictionary, you will get an argument exception error. In order to avoid the error, you can utilize the try add method. It works the same way as the add method, with the exception that if the key already exists in the dictionary, nothing will happen. No element will be added and no error will be thrown. You can remove an element from a dictionary using the remove method. The remove method takes one parameter, the key for the element you want to remove from the dictionary. If you attempt to remove an element using a key that doesn't exist, nothing will happen. You can clear the entire contents of a dictionary using the clear method. The clear method takes no parameters, and using it on a dictionary that has no elements will do nothing. You can check to see if a key exists in a dictionary using the contains key method. This method takes one parameter, the key you're searching for, and will return true if that key exists, or false if it does not. Your IDE shouldn't even let you try to pass a key that's not the same type as the keys in the dictionary. Similarly, you can check to see if a value exists in a dictionary using the contains value method. This method also takes one parameter, the value you're searching for, and will return true if that value exists or false if it does not. Like with contains key, your IDE shouldn't even let you pass a value that's not the same type as the other values in the dictionary. Lastly, if you're curious, you can check the number of elements in the dictionary using the count property, the same as you would with a list. And just like that, you have another powerful tool in your programming arsenal. Being able to group together like-typed elements and call on them via a key of your own choosing has so many uses, I'm sure you've already thought of a few yourself. Arrays, lists, and dictionaries are not the only collections available in C#, but they are certainly the most widely used. And over the next couple of videos, we're going to get real practical with each. So how do you know which collection is right for the problem you have to solve? Well, here's how I decide. Start by assuming that an array will do the job. Being that they're the lightest weight collection, we'll start with efficiency being our primary concern. Determine if the size of the collection needs to change. If it does, you'll need to upgrade to a list. Otherwise, stick with an array for now. Lastly, if you need to address each of the elements in the collection individually, will an index suffice? If so, stick with your result from the last step. Otherwise, upgrade to a dictionary. There is one last item I want to address before we move on from our focus on collections. Collections we've been learning over the past 3 videos are C# collections. They come with the language and are as tightly integrated with it as anything can be. However, there are other collections available in Godot in the Godot.Collections namespace. Now, a reasonable reaction to that news would be, hey, wait, there's Godot-specific collections? Why didn't we learn those? That's because Godot collections are trash. Godot collections are designed to allow any sort of data type to be anywhere in a collection, and not in the same way that generic types work with C# collections. With Godot collections, a single array, which acts a lot like a C# list, can have any combination of ints, floats, strings, bools, and objects in it. A single dictionary, likewise, can store any combination of data, and any combination of data can be used for the keys. On its face, this convenience might seem like it's a great idea, but in order to make it happen, Godot relies on a built-in complex data type called a variant. Variants can effectively be any data type at any time, and to get that functionality, well, let's just say that variants are heavy. So heavy, in fact, the one notable scenario where GDScript is faster than C# is when C# is dealing with Godot collections. Variants can be a very useful data type, but not in collections. You're taking a significant performance hit to ultimately make your code more difficult to read and harder to debug. Stick to C# collections. You'll be happy you did. Homework. Play with dictionaries. You'll get real homework again next time. Pinky swear. Our collection side quest is now complete, and we're going to get into something fun. For the next video, I'm going to have a sample project ready for us to work in together as we start playing with Godot-specific functionality and how it relates to C#. That part of the series may need longer to cook than 1 week, so be sure to subscribe and hit that bell icon to be notified when that's up. As always, it was a pleasure to have you join me today, and I can't wait to see you again. The best to you and yours. Take care.